Today we are going to do a couple of reviews on net force. So you should have already copied the 4 problems that are on the board down into your notebooks, and you should be working on them, or should have worked on them. All right? If you didn't get it, that's all right. I mean, it is kind of easy, and you might want to come in and get extra help. All right? So let's get started. This is the first one. This was number 1. All right? So it says you're trying to find out what the net force is. You have 3 newtons moving this way, okay, and 1 newton moving that way. So that's a total of 4 newtons going up, right? And then you got 15 newtons going this way, all right, and 4 newtons going that way. So that's a total of 19 newtons going down. All right. So what is the total net force? The way you figure that out is you just take these and you subtract them. Okay, so you can get one of 2 answers. You can either get, let's see here, you can either say that it is negative 15 newtons, all right, or you can say that it's 15 newtons going down, okay? These two mean the same thing. And how did I figure that out? What I did, like I said, is I just took this 19 and I subtracted it from the 4. All right? Depending on how you subtract it, if you took the 19 first and you subtract it from the 4, you're going to get a 15, a positive number. If you took this 4 and you subtract it from 19, you're going to get a negative number. All right? But you just need to know this negative means that it's going down, and this arrow also means it's going down. So that means this box is going to accelerate, or another way of saying it is it's going to move. It's not balanced, so it will accelerate. Okay? Next. All right, so then you got this box. Let me make sure I got this right. Okay, good. All right, so now you got 5 newtons going up, and you have 5 newtons going down. So what is the net force? The net force is 0, okay, which means it is balanced. And so if it is balanced, that means it is not going to accelerate. It will not move. Nothing is causing it to move more. Now, if I all of a sudden added another arrow, like even 1 newton, then it would accelerate upward by 1 newton. It would have a force of 1 newton going up. Okay? Next. All right. So looking at this box here, you got a little more going on. So forces always go in pairs. The way you would go about this one is you would take this 3 newtons over here and check it out over there. Notice that they cancel out. So this is 0 newtons on this side. All right? So now you're really looking at these two. And when you see that, you can tell that, okay, this up here is a lot less than this down here. And what is the total net force? Well, you take the 23 minus 14, and you should get, let's see here. Okay, 23 minus 14. You should get 9 newtons going down. Or you can even say negative 9 newtons. All right, one of the two. Okay, next. Now this one is also a little bit more complex. You got all these arrows. This one also looks like what we're going to be getting into, which is a force diagram. All right. This little dot right here can represent anything. It can represent you, a person. It can represent a box. It can represent a ball. It can represent the planet. This dot right here is basically for those of you who cannot draw people. All right, can't draw at all. So we represent it with a dot or a box. Now let's go ahead and solve it. You always want to work on the pair, so let's start off with this one. This is 1 newton going up, 1 newton going down. So you just kind of want to work, you know, when I say in pairs, if you're going to mess with the one going up, you want to mess with the one going down too. So 1 newton cancels out 1 newton, so your overall net force going up and down would be 0, right? Okay, and then you look over here. You've got 6 newtons going to the right, and another 12 newtons going to the right, so that's a total of 18 newtons over here, okay, because 6 plus 12 is 18 newtons. And if you look over here, this is also 18 newtons, which means that this ball is balanced, and these guys will cancel out each other, and your overall net force is 0 newtons, all right, 0 newtons. So it is not going to accelerate, all right, excel. Okay, you get it. All right, thank you.